Welcome back. Example 10. Evaluate integral sine power 5 of x cosine power 5 of x dx. Notice both of these are odd powers. Odd power of sine, odd power of cosine. In this case, we can do the following. Remove one of the powers aside. So I have removed sine power aside. So only 4 powers of sine are left, which is sine squared power 2. Cosine power 5 as it is, sine x dx. So this is going to be du, or in this case negative du. So u should be cosine x. In other words, we want everything else to be in terms of cosine. So rewrite sine squared as 1 minus cosine squared x power 2 power 2. Cosine power 5, cosine power 5, sine x dx, sine x dx. Substitution u equals cosine x gives me 1 minus u squared power 2 u power 5. This is negative du, okay, because derivative of cosine is negative sine. So that incorporates a negative here, bring it out, open this out, 1 minus 2u squared plus u to the 4th times u to the power 5 du. Distribute the u to the power 5, don't forget the negative. Integral u to the power 5 minus 2u to the power 7 plus u to the power 9, okay? That's upon distribution du. Now, negative integral of u to the power 5 is u to the power 6 over 6 minus 2 integral of u to the 7 is u to the power 8 over 8 plus integral of u to the 9th power is u to the 10th power over 10 plus a constant of integration, negative outside, replace u by cosine, negative cosine power 6x of over 6 minus 2 over 8, that's a 4 in the bottom, cosine power 8x plus cosine power 10x over 10 plus a constant of integration. So this is when at least one of the powers is odd. Okay, you remove one of the odd power combination out and proceed. Now what happens when both are even? At this point you will need to use the twice angle formula. What is the twice angle formula? Cosine squared is cosine 2x plus 1 over 2. Sine squared is 1 minus cosine 2x over 2. So that's the twice angle formula. We saw how we derived this earlier. Now, so sine to the power 4, cosine to the power 4. Sine to the power 4 is sine squared power 2. Sine squared power 2. Cosine to the power 4 is cosine squared power 2. So cosine squared power 2. All right. I hope this is clear. This is sine squared. This is cosine squared. Power 2, power 2. Now, power of 2 of 2. So that's a 4. Another 4. So 4 and 4, that should be a 16. Okay. So make that correction. It should be all 16s here. Anyhow, taking powers here, 1 minus cosine power 1 minus cosine 2x, and this is actually 1 plus cosine 2x. So that's difference of squares formula. 1 minus cosine 2x and 1 plus cosine 2x is 1 minus cosine squared 2x. Power 2, power 2. 1 minus cosine squared is what we call sine squared. Okay. So 2x, 2x. Now again, because this is even power, I will use sine squared twice angle formula. Sine squared is 1 minus cosine of the twice angle. So this is 2x, its twice angle is 4x. So I have rewritten sine squared as 1 minus cosine 4x over 2 power 2. Okay, so that's a 4. This should be a 16, remember? So that should be double 64. Anyhow, so that's just a constant. So make sure you make that correction. I get 1 minus 2 cosine 4x plus cosine squared 4x dx. Okay, So we have resolved from power 4, we have come down to power 2. But anytime you have an even power, you use twice angle formula. So notice this is cosine squared 4x. Its twice angle is 8x. 1 plus cosine 8x over 2. That 1 over 2 combines with this to give me 3 over 2. 3 over 2 minus 2 cosine 4x plus all of this cosine 8x over 2. When I take integration of this, I get 3x over 2 minus 2. That integrates to sine, don't forget, over 4. This integrates to sine 8x, don't forget, over 8. So that's a 16. So all of this is correct, except this should have been a 16. 2 squared is 4, 2 squared is 4, 4 times 4 is 16. So all that is 16, that becomes twice, 64, 64, 64. Everything else is good. All right. Evaluate tan power 5, secant power 5. Now here we are going to use tan squared is secant squared minus 1. Okay. Now tan power 5, secant power 5. Well, I'll remove one of the tans aside, one of the secants aside. Tan squared, tan power 4 is nothing but tan squared power 2, which is secant squared minus 1 power 2. Secant power 4 is secant power 4. Why did we do all this? This is going to be du. What is u? U is secant. Derivative of secant is secant tan. So all that is du. So that's u squared minus 1 power 2. Secant is u. And secant tan dx is du. So this is u power 4 minus 2u squared plus 1, that's this, times u to power 4 times du. So it is very important, remember tan squared is secant squared minus 1. So what did we do here? They were both odd powers, so we removed one power each. That gave us the du. Now even powers we dealt with using these identities. So distribute the u to the power 4, u to the power 8, u to the power 6, u to the power 4. Now you integrate, all right, plus constant of integration and replace u by secant. That's it. So that was when they were both even. Now what happens is one is even, they are both odd. Okay. Here tan squared is secant squared minus 1. So we are going to do the same thing. But instead of taking away one tan and one secant each, we'll take away secant squared. Okay. Why did we do that? In a minute you will see. So tan to the power 4 is as it is. Secant power 4, I've split it as secant squared and secant squared. So I took away one of the secant squareds. All right. Secant squared itself is 1 plus tan squared. Aha, what happened here? Secant squared dx is going to be du, in which case u has to be tan, and that's why we rewrote everything in terms of tan. All right. So once we do that, this is du, this is u, and we continue. U to the power 4, so on and so forth. Replace u by tan. So what happened here? They were both even. So we took secant squared out and proceeded. Okay. So here what did we do? We took one secant, one tan out. So mind you, if you have odd numbers, you would do this. But if you have both even, that's the strange one. You replace, you remove secant squared. So it depends on the context. All right, it depends on the context. So if what happens if you have secant in the even power, then you can do this. All right, but the moment secant is odd, you would have to resort to this. All right, now here are two important formulae. Integral of tan, this we saw in our earlier lectures sometime. Integral of tan is natural log of absolute value secant plus constant of integration. Integration of secant is natural log of absolute value secant plus tan plus constant of integration. So these are important formulae we saw quite a few sections ago. Now what does that mean? Integral of, so this is 1 power of tan, 1 power of secant. We know how to handle them. Now 2 powers of tan or secant can happen like this. Integrand of secant squared is simply tan. What about integral of tan squared? Tan squared is secant squared minus 1. Well, you know integral of secant squared, that's tan. You know integral of 1, that is x. So that's also doable. When they are both 1 each, then it is simply secant. So you know degree 1, these are all degree 2. Now higher degrees. Now I have only tan power 5. So this is an odd power of tan greater than 1. So now you are going to use the fact that tan squared is secant squared minus 1. How? Well, tan to the power 5, I'm replacing, I'm splitting them as tan squared and tan cubed. Tan cubed, tan squared is secant squared minus 1. Aha. Now combine, multiply these two. You get tan cubed, secant squared minus integral tan cubed. What is tan cubed? So this is again an odd power. Split it again. Tan squared. Tan squared is secant squared minus 1. So tan secant squared minus plus 1 times tan. Okay. So why did we do all this? We reduce the power of tan to tan cube, then tan and tan. So what happens here now? So you have secant squared, combine these two integrals together, tan cube minus tan. We went through all this rigmarole just to get a secant squared because that is going to be your du. Tan x, integral of tan x is straightforward. You know this by formula, natural log of absolute value secant. This you are going to get it by substitution. So notice what happened. Tan to the power 5. We removed a tan squared aside so as to get it into secant squared mode. Once you have secant squared dx, that is your du, and this is u. U equals tan x. Integral u cubed minus u du plus, when you have boiled it down to just 1 power of tan, you know the integral already. So integral, you are done with. Now this was when you had an odd power of tan. Let's look at an even power of tan. Looks like the game is same. I'm separating the 4 powers as power 2 and power 2. Tan squared is secant squared minus 1. So that gets me a secant squared minus integral tan squared. Tan squared again is secant squared minus 1. So that's minus integral secant squared plus 1 integral of 1. So this is going to be u, substitution u equals tan. That gets me u squared, that's a du. What is integral of secant squared? That's a formula, tan. So you are set, u cubed over 3 minus tan x. So either way, high power of tan, what do? You take 2 powers of tan aside, get secant squared in your game, and that reduces power of tan. Keep doing that until you are able to integrate. Okay. 1 power of tan squared gets me secant squared minus 1. Secant squared dx is my du. Alright. We'll continue now with higher power of secant in our next video.